Today I'm going to show you how you can make pictures like these using your Dobsonian on equatorial platform. I'll show you how to prepare the telescope for the night, how to polar align your equatorial platform in SharpCap, how to search for the targets and start live stacking. At the end, I will show you the result. First, we need to place the equatorial platform. I'm using this table where I have pre-marked spots where I am putting my equatorial platform. So I have placed the equatorial platform on the table. The role of the equatorial platform is to track the stars. On this side we have the part of the platform which has vertical north segments that are sliding on those shafts. Those shafts are powered by two NEMA 17 stepper motors and are being operated through the logical Arduino unit. Here I have end stops, so basically when the vertical north segment hit this switch, this end stop, the rotation of the platform finishes and moves back to the original position where there is another switch. So the orientation of the platform is crucial to have precise star tracking. So the northern part of the platform is here, the southern part is here. Southern part is consisting of a simple pivot point which is placed to the direction of the celestial south. So the Dobsonian mount goes on the upper plate of the platform to make sure that the telescope is properly aligned. I am putting those legs on the pre-marked spots on the upper part of the platform. To make sure that the base is properly aligned, I use this screw and those markings that are showing the middle part of the upper table, and I try to align it to the best of my possibilities. Then during the night I will do the proper polar alignment using SharpCap software and the polar alignment feature. The last part is to put the Dobsonian on the mount. And this is re-rotating to the pole star, which is at around this latitude. So that way the south is pointing towards the pivot point and the north is pointing towards the Polaris star. Just one more thing I forgot to mention. You have to have the platform leveled, so this is why I have here two bubble levels, and you can see they are roughly aligned, so the equatorial platform is leveled. Start by pointing your telescope at Polaris. In SharpCap Pro, go to Tools, Polar Align. In the alignment window, make sure to enable the option under Advanced, Allow smaller rotation angles. This is important because EQ platforms typically rotate only about 20 degrees compared to full equatorial mount used in astrophotography. SharpCap will plate solve the image and prompt you to continue. It will then ask you to rotate the array axis. In this case, you need to manually move the platform from its starting position to the end of its travel. After that, SharpCap calculates your polar alignment error. When SharpCap asks you to move the array axis during polar alignment, meaning left and right adjustment, position yourself at the southern side of the platform where the pivot point is located. From there, move the northern end of the platform either to the right or to the left as instructed. If SharpCap asks you to adjust up and down movement, it is referring to the altitude angle or declination of the platform. In this case, a down adjustment means you need to raise the southern side of the platform, while an up adjustment means you need to lower the southern side. Proper polar alignment requires combination of both array left and right movement and declination up and down movement. After a few iterations, you should be able to reach a good polar alignment. Once satisfied, return the platform to its starting position and begin locating your target. Before that, I recommend checking focus using a Batino mask on Polaris or any bright star. Make sure that the spikes are even. That shows that you have a good focus. SharpCap also has a very useful push-to assistant, which works great with the manual Dobsonian. Simply select your target and follow the on-screen instruction. Movement is always done manually, left, right, or up, down. Once the object is centered in the field of view, start the platform tracking and adjust your capture settings. In my example, I used gain 100 and 30-second exposures with a Touptek 2600C camera. Since this is a DIY platform without guiding, you can expect some drift in the field of view. Achieving consistent 30-second exposures is quite challenging. You need calm wind conditions, good seeing, and accurate polar alignment. Even then, I had to discard about 30% of the frames. I captured the Horsehead Nebula over 3 nights, completing a total of 5 platform cycles, each lasting about 65 to 70 minutes. The final image was processed in Pixinsight, and here is the result. Enjoy!